So I want to have a look at this HSC 2006 question from extension 1 of the topic of binomial probability. And before I show you, my first kind of reaction to seeing this question was, I think the best way to summarize it, there's this quote from The Office where Michael Scott goes, he says, "I knew exactly what to do." But in a much more real sense, I had no idea what to do. And that's kind of how I felt about this. This question over here, when I first saw it, there's this kind of wall of text that just kind of overwhelms you a little bit with the information that's going on. First of all, what's the context of this? Well, it's an event where there's a probability that you will complete the course or not, right? So the probability that you will complete this particular course is P, and that you won't complete it is Q, which is the complementary 1 minus P, right? And then you start incorporating all this other information, like it's got 2 or 4 competitors. Okay, I don't really know what to do with that just yet. And you score points if at least half its members complete the course. So I guess the context kind of makes sense. So you're going into this competition where maybe you have 2 or 4 people, and the way you want to complete the course is if at least half your members complete it. So maybe like 1 completes it, or 2 completes in this case, or here 2, 3, or 4 people complete the course, right? So that I'm sort of okay with. Then it starts to get a bit curly because it says show that the probability that a 4-member team will have at least 3 of its members not complete the course is this. So here's where I'm starting to get a little confused how exactly I'm meant to arrive at that. Let's just write that down first. So part 1, it's I need to show that at least 3 in a 4-member team at least 3 won't complete. We're required to prove, RTP, that that's the same as 4p cubed. 4pq cubed, it's a bit wordy, plus q to the power 4. And great, it's 1 mark. So what do we do with that? So let's just get a bit of a grasp on what the situation is like here. If I want at least 3 members not completing, I want to write all the different scenarios that can happen. So for example, at least 3 means that I could have 3, right, that don't complete. But then I can also have 4 that don't complete, right? So that's just a visual sense of what's going on. Now, because this is a topic of binomial probability, and the reason I know that is because I have a certain number and I'm picking from them, right? So I have 4 and I'm picking 3, for example. So that should already get you thinking about binomial probability. And we have a formula that represents that. We know that we can find NCR, P to the R, Q to the power N minus R, where N is kind of the number you're picking from, R is how many you want of this particular thing, P is the probability of success, Q is the probability of failure. Now, what you have to be a bit careful of here is that they've kind of used P and Q, but what we're looking for is not completing. So you can readjust it in any way you like, but what I'm going to think about is I'm going to think about not completing as my now P, right? So it's a little bit confusing, but that's the kind of what I'm looking for. That's what I'm looking for in this case. But we know that this probability that they gave us, that was actually Q. So yeah, that's something you just need to be aware of, right? So is it P or is it Q, depending on how you define your variables, right? But let's come back to this. So you can see that this is the probability that 3 won't complete, and this is the probability that 4 won't complete. And essentially what we're going to do is we're going to add those 2 values together. Okay, so let's go ahead and do that. So at least 3 won't complete will be P of 3 plus P of 4. And how I'm going to write this out is that's going to be 4C3. Now, what's the one that I'm interested in? I'm interested in not completing. So that's actually Q there, isn't it? So that's Q, and we're going to raise that to the power of 3. So that's Q cubed. And then, obviously, if I'm picking 3 that won't complete it, then I want 1 person that actually does complete it. So that's P, my probability that they will complete. And then we can add the other one. So 4 not completing, that one's a bit easier because I'm picking 4 that won't complete it, right? So that would be Q to the power 4. And well, P, that's just going to be P to the power 0. That's just going to be 1 anyway, right? So we can simplify this out a little bit. 4C3, you put that in your calculator, that's equal to 4 Q cubed P, and then we just get left with Q to the power 4 here, right? So actually, it turns out, once you look at the problem and break it down a little bit more, it does become quite approachable now, because we can just rearrange this and we get what we had to prove, okay? That's the first part. Now, the second part, if I go back to it, asks us to say, okay, well, now that you've done that, hence or otherwise, find an expression in terms of Q only for the probability that a full-member team will score points. So go back to, this is where understanding the situation is really important. How do you actually score points? You score points by saying, all right, well, if at least half of your team completes, right? So let's go to part 2 now. And I don't tell me something I'm required to prove. So something along to say about that is, even if you can't get part 1, you can at least use it here because it says hence or otherwise. So that's a bit of a clue for you to use this. Now again, we want that the full-member team will score points. And the way that they do that is that at least half of its members complete the course. So again, I'm going to get a bit of a visual representation of what's going on here. So we want to know the expression, I think in terms of Q, that they will complete. Will complete, that's a 4-member team. Okay? So when does that happen? Well, let's kind of get our visual representation again. So at least 4 members completing. Well, you can have 2 members completing. So I guess the crosses mean they don't complete. So these guys did complete. We could have 1 member not completing. And we could have no members not completing, or basically all members completing, right? And what you notice is, why do you think they sort of related these two together? It's because if you think about these situations here, right? I'll just write these out. So this is probably of 2 not completing, probably of 1 not completing, probably 0 not completing. If you think about these actually make up the whole sample space. These actually encompass everything that can happen, right? Because you can have none complete, 1 incomplete, 2 incomplete, 3 incomplete, 4 incomplete. That's all the things that can happen. And what that means is that these two are complementary events, which means that we can use our kind of complementary probability rules, right? Because if we add all of these together and all of these together, they should equal to 1. And so for part 3, since they're complementary events, what I can say then is that the probability that the 4-member team will complete is equal to the probability that 2 don't complete, 1 doesn't complete, and 0 don't complete. Or you could just say that's 1 minus what you found over here. So there you go. Yeah. So 1 minus p of 3 plus p of 4. That's just 1 minus this guy here. So 1 minus 4p cubed plus q to the 4. Make sure you put brackets, otherwise it won't be quite right. And then that gives us, well, I mean, it doesn't really simplify it nicely, but you know, you can leave it like that or just expand out that bracket as well. So that's our expression that the 4-member team will complete is this. And the answer said only in terms of Q, so we should, I guess, actually rearrange this here and just say that P there, well, how do we rewrite P? Remember in the question they gave us that P is the probability that they will complete, and Q, which is equal to 1 minus P, is that they won't complete, right? So that guy should be like 1, well, if Q equals to 1 minus P, then P would equal to 1 minus Q, just rearrange it, right? So that's 1 minus Q cubed minus Q to the power 4. Yeah, not the nicest expression, actually. Can we expand that? Oh, maybe we can expand it. So 1 minus 4 plus, actually, you know what? Let's expand that inside part first. So 4, that becomes Q cubed minus Q to the 4. And then that becomes 1 minus 4Q cubed plus 4Q to the power 4 minus Q to the power 4. It does simplify a little bit, actually. So 1 minus 4Q cubed plus 3Q to the power 4, I guess, is our expression in terms of Q. Okay? Sorry. All right, now we can answer this question properly. So if we can just have a look at the, how do I do this? Yeah, just try to read it there. So part 3 says, find an expression in terms of Q only, so you gotta remember that this time, for the probability that a 2-member team will score points. So this is part 3 now. For For the two-member team will score points. Well, if you think about the two-member team, right, how do they score points? Well, they can have one person incomplete, or they could have no people incomplete. So 1, 2, right? And when would these happen? So this is for the two-member team. Do we need to use binary probability for this one? It's kind of like a 2 choose 1 situation. So you could just kind of work it out without binary probability. But I'll write it out just in case anyway. So this situation over here, so I'm saying from 2 of them, I'm choosing 1. Now I'm going to stick with the incomplete because that's kind of how we've been writing it, right? So I'm going to stick with the 1, choosing that as my success. So incomplete is Q, and I want one person to do that. So that's Q to the power 1, P to the power 1 as well. Cool, that's one person incomplete. And then same thing over here. I want 0 to incomplete now, so Q to the power 0, P to the power 2. Now, obviously, I said only in terms of Q, so we might as well make that substitution now. So instead of P, I'm just going to write 1 minus Q. And instead of P here, I'll also write 1 minus Q. Okay, so 2 choose 1, that should be 2. So from here, let's just kind of simplify this a little bit. So 2C1, that's just going to be 2. I'm just going to leave this Q, 1 minus Q here for a second. 2C0, that's just going to be 1. Q to the power 0 is also 1. And then I get 1 minus Q all squared. Now here, I could actually factorize out the 1 minus Q. So let's do that. 1 minus Q outside of 2Q plus, I get left with 1 minus Q here again, if I factorize one part out. And this can actually simplify a little bit. So I get 1 minus Q outside of Q plus 1. Interesting. Looks like a quadratic there then. Okay. And one thing you can do is just to simplify a little bit is that this, if you rewrite it, 1 minus Q, 1 plus Q, that's actually a difference of 2 squares. So that's just 1 squared minus Q squared, or 1 minus Q squared, right? Now, at this point in time, I've got all this writing here, let's just realize what the last question is. So I'll scroll down a little bit. So last one, hence or otherwise, find the range of values for Q which a two-member team is more likely to score than a four-member team. So when you think about more likely, like what have we been doing? We've been finding these expressions for probability. Like I just got this one. This is the probability that a two-member team will complete. So that's for 2 members, right? And then I also found the probability that a four-member team will complete. It's over here. It's just shoot what I was writing. So let me get rid of that for you. The four-member one that they will complete is this guy here. 1 minus 4Q cubed plus 3Q to the power 4. All right, perfect. Now, the last question that we had to do is to score points in a four-member team. So basically saying, when is this bigger than this, right? So that's why they've kind of led you down this path of finding these individual probabilities, because now they're asking you to compare them, right? So let's go ahead and do that. Find the range of values for which the two-member is more likely to complete than a four-member, right? So we have those expressions there. So that's 1 minus Q squared bigger than this. All right, let's have a crack. So how are we going to do this? Well, first of all, it's an inequality. Is there anything I can do with this? What I could do is, well, these ones actually divide through, so I can get rid of those. That's fine, I think. 1 minus 1 is 0, yeah, so that's fine. So I've got mine, and I'll put all the Q's to one side, let's say. So which side do I want to put them on? Let's keep them over here. So 0 less than Q squared minus 4Q cubed plus 3Q to the power 4. Here we could divide both sides by Q. Now there are sometimes issues with that when you're solving equations, like you may lose solutions, but I don't think it's going to matter in this particular case because we're solving where one side is, yeah. But I don't think that's going to affect us in this case, we'll see. So Q minus 4Q squared plus 3. In fact, we can divide both sides by Q squared, can't we? So let's just do that. So we're going to get q, not q, if I'm dividing both sides by q squared, I'm going to get 1 minus 4q plus 3q squared. And that's looking a bit nicer because that's a parabola, it's a quadratic rather than trying to solve for a quartic. Cool. And then...
Why are you doing this like, yeah, college, you're just filming it.
Yeah, well, Eva wanted to know how to do this one. So let's finish it off. How can we got up to this point here. So I guess if you weren't here before, ignore all of this. So this guy here, this is like an equation, right? But what kind of equation do we call this guy?
Simultaneous.
Yeah, what's a simultaneous equation? Simultaneous means when there's two of the same thing, right? So if there's two equations that you've got and you put them together, that's a simultaneous equation. I've only got one equation over here, right? It is a quadratic equation. Hey, what is this guy?
That's a grade.
Yeah, it's like the one you want to eat the bigger side, right? But to solve something like this is a bit trickier because it's a quadratic inequality. So there's two issues there. First of all, it's a quadratic, and then second of all, it's an inequality, right? So the best way to do that and go about solving that is with like a, I like the visual way of doing it. So I'm going to rearrange this a little bit here.
You probably want to like put into factorization.
Yeah, because you actually want to kind of sketch it, right? So what we do is...
I'm trying to do it in your time.
Yeah, I'm about to. We're filming.
So what we want to do is factorizing this guy. I reckon Maylin could have a crack at this one. PSF.
I'm so bad at these.
I believe in you. What multiplies, because if it's non-monic, what do we need to do here?
Multiply, yeah, so 3.
Yeah, nice. And adds to
Minus 4.
-4. So what are my factors going to be?
I don't know.
Negative 1.
-3, -1?
Negative 1 plus 4.
Well, be careful because it needs to multiply to 3 though, right?
Oh, sorry. I
Yeah.
did the other way around.
So two things, and it's easy because 3 only has two factors, right? 3 and 1, right? It's just like the combination of negatives you have to be careful, and that's where you use the sum, right?
Negative 1.
That's right, yeah, nice, Melly. Extension 1 maths, that's all you.
Extension 1 math.
That's it. So 3q squared, minus 3q, doesn't really matter which way you do it, plus 1. And then we go about factorizing this guy out. So we get q minus 1, take out the negative here, q minus 1.
You shave. Why is your face so...
Oh, and then we get this guy.
And then draw the thing.
Do the thing. Julie, do the thing.
So there's been a really well-paying attention class.
Okay, so then how do we sketch this guy?
Do a graph and then do the above 0 thing.
So above 0, let's have a look. This guy here is a parabola. What are its intercepts here?
1
Yep.
and 1 over 3.
Good. Yes,
yeah.
and 1 over 3. Yep.
Ooh.
So that looks like this guy.
Well, I totally would have done this.
Yeah. So,
As an extension one.
oh wait, you want it less than 0.
Yeah.
Oh yeah, true. Oh yeah, bro. It was right the whole time. So we want it less than 0. So then what's our,
We just want a little bump.
we want a little bump. All right, so that's for q in between 1 and 3 and 1, and then that's our answer for what values of q make this true. So,
So I got it wrong. I got
yeah.
it right.
Well done, Harry.
What happened? We've gone for ages. How's it not done?
Oh, because I thought I made a mistake, but I didn't. So.